As we all know, the COVID-19 global pandemic has proven to be the most catastrophic event in the 21st century, reaching a huge death toll of almost 3.5 million people worldwide. It has also given us a new perspective on how to interact with one another due to social distancing, as well as a new understanding of our world needs. Therefore, during our numerical methods class, we started a project based on developing a digital image processing tool able to help medical workers with radiological image processing, and as a result, achieving a better COVID-19 diagnosis based on these processed radiological images.
Nearest neighbor interpolation is the simplest approach to interpolation. Instead of calculating an average value by some criteria based on complex rules, this method of interpolation can simply determine and calculate its nearest neighbor pixel and assume its value. Therefore, this is the method that requires the least amount of processing time. Furthermore, it's a method of multivariate interpolation in one or more dimensions. The algorithm selects the value of the nearest point and does not consider the values of neighboring points at all, yielding a precise weight constant interpolation. In other words, it only considers one pixel, the closest one to the interpolated point.
To achieve the solution proposed, throughout the project we used different numerical methods and coding algorithms in MATLAB. In this first section, we can see a tiny function that can help us achieve a JPG image from a DCOM image. A DCOM image is a type of radiological image used in the medical field. Some other functions we learned throughout our project in MATLAB were how to divide images, also how to resize them, and also how to give it contrast or a negative contrast. As we can see, as a final product, we achieved an image processing tool that was able to turn a DCOM image into a JPEG image, and then section it into 4 parts. That way, we can choose a specific section and resize it. The program also gives the resized image a contrast and also a negative contrast. Therefore, doctors can see through the X-rays better and also give a better diagnosis. To sum everything up, we were really happy with the results we got. We were able not only to learn about numerical methods, but also put them into practice into a social cause. Helping others in these difficult times of COVID-19 really put us into perspective about what's really important and how, as engineers, we can help each other out. That's why this project was really important to us, not only in the professional field, but also in the social and personal field, and how we grew as persons, learning how to help each other through technology.